So if you want to understand the physics, so to speak, or natural philosophy of the anachronistic, you have to understand what principle, that is bounded by using. And Leibniz talked about three principles. One of them is the law of non-contradiction. That the proposition cannot be true and false at the same time. You cannot say that it's snowing now, it's true, but it's also false at the same time. And Leibniz's view is that this single principle is sufficient to demonstrate every part of arithmetic and geometry. So meaning all what we call mathematical sciences. So basically everything else, according to Leibniz, follows from that. And so it's a very important principle. The natural philosophy is mathematical. I mean, the mathematical principle of natural philosophy, that's the Newton's theory is the mathematical principle of natural philosophy, then this part is very important. The second principle that is very important for Leibniz is the principle of sufficient reason, and it's that nothing happens without reason, why it should be so rather than otherwise. The principle of sufficient reason is not only Leibniz's principle, it's actually a principle that is accepted by many of his many contemporaries, of Leibniz. So they use it, for instance, in probability. Many of you use the principle of sufficient reason even without knowing. You toss a coin and you say the probability is half and half. Why? Because there is no sufficient reason, to choose one or the other. And so on. So whenever there is no sufficient reason, for instance, and there are different possibilities that may have probability, you give the same probability. So there were a number of people, including Leibniz, that used, for instance, the principle of sufficient reason to determine probability. But in general, the principle of sufficient reason for Leibniz is a very, very important metaphysical principle that from the mathematical principle, together with the principle of sufficient reason, you can actually derive a lot of things. So for instance, you can derive that Leibniz argued on the basis of this principle that can prove the existence of God and all other parts of metaphysics and natural theology, and even some measure principle of natural philosophy that are independent upon mathematics. He means the dynamical principles, so for instance, like Newton's law. According to Leibniz, we think that he can actually say a lot or learn a lot about the nature of space and time, the nature of the law of motion, and so on, just from the principle of sufficient reason. So it's both in theology, in metaphysics, and what we call, in natural philosophy, what we call life physics. And then there is also, Leibniz talks also about the principle of identity of indiscernible. There is no such thing as two individuals indiscernible of each other. So for instance, if you think about 2 points, 2 points are supposed to be totally identical, no? All points are identical. So it's a problem, for instance. So, or if you think about 2 electrons or 2 atoms, if 2 atoms are just the same, then according to this principle, if there cannot be 2 things that are just the same. And Leibniz actually used this principle, to argue, for instance, for the nature of space and time. He has a different view than Newton's. Leibniz seems to motivate the principle of the identity of indiscernible from the idea of from the principle of by the principle of the sufficient reason, though it's not clear whether this principle really follows. By the way, the principle of indiscernible, of identity of indiscernible, is used even nowadays, to discuss and analyze quantum mechanics. For instance, there are identical particles in quantum mechanics, and people consider quantum mechanics in order to see whether we should support this principle or not. But in general, identity, we all determine identity by the properties of things. So if we think that two things are different, we always think that there is something that separates between them. So even, identical twins are two things, two different things, because they are never in the same space at the same time. Okay. So read this question, read the whole correspondence, and you think about it, maybe you will have an answer, but it's not an easy question. So the principle of non-contradiction, the principle of sufficient reason, and the principle of identity of indiscernible are the principles that guide Leibniz, philosophical and theological thinking, and based on this principle, he argues that God created the best of all possible worlds. So God actually considered, according to this principle, what are all the possible worlds and created the best one. So if you suffer sometimes, be assured that that's the best overall of what can be. And accordingly, Leibniz thinks that it doesn't make sense that God, if he created with all this thinking, they consider all continuous infinite possibility of other worlds, that he will have to intervene in the world constantly. Just, this is something that you cannot actually understand. For Clark, God's will is the final arbiter. So God basically, in colloquial language, God does what God wants. And obviously, Leibniz would agree with that, but Leibniz would think that the will of God is subjected to the principle of reason. So Leibniz thinks that God would not want to do anything that is against the principle, the principles of reason, but Clark, like a number of other people, think that don't tell God what to think about, because we are too small. God is infinite, has infinite thinking, we have only finite thinking, so we cannot understand what God really, at the end of the day, why God decides one way or another, so it's God's will is a sufficient reason at the end of the day. So he agrees with the principle of sufficient reason, but he doesn't agree with the understanding or interpretation of Leibniz. He thinks that Leibniz, in his way, in his understanding of the principle of sufficient reason, and the use of this principle and the other is too restrictive. So we will come back to that. But basically, that will is enough as a sufficient reason. You don't need any other explanation for God. And for Newton. Okay. So that's what he said. It's very true that nothing is without a sufficient reason why it is and why it is done rather than otherwise. But this sufficient reason is oftentimes no other than the mere will of God. There can be no other reason but the mere will of God. For instance, why this particular system of matter should be created in one particular place and then in another particular place can be no other reason than by the will of God. So basically, if God decides to create, Earth, for instance, is the place for human, it's just because of the will, and there is no other reason. It's not that you can find kind of sophisticated explanation, or there might not be such an explanation. And the explanation is that God decides. That's the will of God. Okay. And God also thinks, and Newton as well, that constant intervention in the world is not a problem at all. So he rejects, as we can see, Leibniz said, the number of objections to the intervention of God in the world, and he rejects this objection And he thinks, as a matter of fact, that that intervention is a good thing. It means that God is in contact with us all the time. It's not a kind of distant God that decided, how the world should go. And it's God that always, intervenes in the world, and it's a sign of His glory, power and glory. But it's not an evidence of like God that cannot create a good world or the best of possible world. Well, we will see all this, in the second presentation. Okay. Leibniz and Newton are also sometimes, that's kind of misleading, but remember that we talked about the distinction of the contrast between rationalism and empiricism. So there is a question always in philosophy and in science, in the history of science. What is more important, reason or observation? And basically everybody agrees that reason and observation are important, but the degree to which, different philosophers and philosophies give importance to reason and empirical facts, or observation and experience, varies. Now, Leibniz is considered more rationalist among the early modern philosophers. He is among those who are considered rationalists. He thinks, it's not that he doesn't look at observation when we think about natural philosophy and think about the principle of motion, but he thinks that you have to start from the principle of reason and try to explain it and to create physics, along these principles. Newton is considered more empiricist, so there is a contrast between them. So basically, Leibniz, in our words, would say that you have to take metaphysics very seriously when you do physics. So you have to take metaphysics and teach people, in the department of physics and other department of science, that do physical science, metaphysics, because that would make the physics better. And obviously, God, used this principle. And God created the world. It's kind of obvious that you have to create this. Clarke and Newton are considered more empiricist than rationalist. And Newton, for instance, he has his theory of gravity. And in Newtonian gravity, there is a force between different objects, even when they are at a distance. And this actually, is immediate force. And so it's an action at a distance. And Leibniz and a number of people of his time, Newton and Leibniz's time, find it very difficult to accept action at a distance. It's a kind of magic or something like that, or strength. Especially given that they had a philosophy of metaphysics that is mechanistic, of possession. There is mechanism that actually is responsible to the fact that the stars, for instance, attract each other, and the sun attracts the planets and so on. But in action at a distance, there doesn't seem to be such a mechanism, so it's a problem. Nevertheless, Newton says, I don't understand action at a distance. He says, in various places, he said this, that it's a problem, but then he's not willing, to give up Newtonian mechanics. It's empirical, good theory. For Leibniz, that's not acceptable. You need to have a physics, or natural philosophy, as we should say, that is according to the principle of reason, and he thinks that, this would not, stand to the test of the principle of reason. So he doesn't like to be Newtonian, although it's a very successful theory. So they have different views, and such view you can also find in science. Nowadays, science goes more in the direction of empiricism, but there are people who, for instance, don't like quantum mechanics because they think it's a very successful theory, but it doesn't make good sense. The quantum mechanics that is taught in classes. Yeah, it's a good oracle. You can use it to predict and that, but when you try to understand what it says about the world, you find that it doesn't make a good sense. So many people, for instance, or more and more physicists and philosophers look for alternative to quantum mechanics in order to have a theory that would account for the prediction of quantum mechanics that would make sense. Now, one of the explanations that is sometimes used and hinted maybe also by Newton and Clark is that action at a distance is actually God mediates the action by the influence of one body on another. So that means that infinite number of interventions all the time. The fact that I stand here, God maintains it all the time. This gravity. And obviously, Leibniz said that that makes sense. What kind of God is it? Like another thing. And it's to work so hard. To have to. Okay. Leibniz and Newton also disagree on the view of space and time. Newton believes that space and time have absolute existence independently of any objects. They are like big containers in which everything, all the objects, we, planets, and everything else, everything that there is in the universe is in this container. In a sense, Newton is like the block universe, if you want, view of space and time. So there could in principle be a block universe that is empty of objects. That's not impossible. It's not our universe, we know, but it could be according to that. The existence of space and time are independent of the existence of the things that are in space and time. For you. But Leibniz has a very, very different view. This is always interesting. So Leibniz thinks that space and time has no independent existence of the things that are in space. So if there were no objects, there would be no events, there would be no space and time. Space for Leibniz, and that's kind of not an easy idea, is the order of coexistent phenomena. So as such, it represents relation between things. So think about a universe in which there are things. Space doesn't exist as a container, but space is basically a codification of all the possible relations between things. So when I say that I'm distant from you 2 meters, it means that some of the relationship between us, like for instance of attraction, are such that would be in Newton space-time corresponding to a gravity of 2 meters difference. So if you want, space, it's a kind of geometry. What you learn geometry is a map. Basically, space, in that sense, it exists, but it exists as a set of relations. So if you want, when you say space, when you put the block universe, for instance, for Leibniz, it's not really a block universe. It's just a map that summarizes the relationship between things. I know it's difficult to understand what it is exactly, but it means that space in itself is not a container, it doesn't exist. It just, space only represents, when we say space, and we have Euclidean geometry, for instance, it just represents relationship between things and their properties. They are in space because they have relationship. It's not they are in space to start with, and then you see the relationship. So I said that I'm like 2 meters away from you, not because there is a container in which I'm 2 meters away from you, just because our relation of, for instance, a relation of repulsion and attraction. I mean, that people are such that they are weaker and that they are stronger than the relationship from someone who is 4 meters away. So it's a difficult thing to understand, but it means that space and time and distances between things are not something that exists independently of things. It's just when you have the arrangement of all the things and the relationship between them, not the arrangement with space-time, but the relationship between things. One thing is heavier than another, one repels more than another, for instance, and so on. Then you can codify all these as something that we call space. So it's like a map. It's like a map that summarizes all the relationship between things. And the same for time. Time is the order of successive phenomena, and as such it represents relationship between events. So time basically just is not that it exists independently and run and flow. Or like in the block universe is another dimension that exists independently of whether there are things. Time is just a summary of all the relation of the events between events, the successive events. Or events, that happens. When we say that one event is before the other, it has a different relationship than when we say 2 events are at the same time. But it's not that time exists before. It's the events that